All right, so you've been grinding through the basics of integration, right? But have you ever stopped to ask, what's the actual point? Where do we use this stuff? Well, today we're going to level up. We're going to use that skill to solve a huge problem, finding the exact area of all sorts of complex, curvy shapes.
Think about it. We all know how to find the area of a square or a rectangle. That's easy, just length into breadth. But what about something like this? Imagine this curve represents the views on a viral YouTube video. How would you calculate the total watch time under that curve? Suddenly, our old geometry formulas just don't work. We need something way more powerful. You see, your old formulas are good, but they have their limits. It's like trying to defeat a final boss with a basic starter weapon. For these complex, unpredictable curves, you need to unlock a new superpower, and that superpower is integration. It's what lets us measure what seems totally unmeasurable. Okay, let's get into it. So, how does this superpower actually work? It's all based on a really simple but totally brilliant idea called the slicing method. The main idea here is surprisingly simple. Instead of trying to measure this whole weird shape at once, we're going to slice it. Think about it like scanning a QR code. Your phone doesn't see the whole thing at once, it scans it line by tiny line. We're doing the same thing here, slicing this big area into thousands of super thin vertical rectangles. And the area of a rectangle, well, that we definitely know how to find. Each one of these tiny rectangular slices has a proper name. We call it an elementary area, or just dA for short. So what's its area? It's a rectangle, so it's just height times width. The height is simply the y value of the curve at that point. And the width, since it's an incredibly small change along the x-axis, we call it dx. So the formula is simple. dA equals y times dx. And here's the best part. To solve basically any of these problems, you just need to follow this 4-step game plan. Think of it as your cheat code for calculus. First, sketch the regions so you can see what you're dealing with. Second, define your elementary strip. Just draw one of those tiny rectangles. Third, set up the integral to add them all up. And fourth, solve it and you're done. All right, it's time to get started on our main quest. This is the classic, most common type of problem you're going to see, finding the area of a region that is neatly sitting above the x-axis. So we have all these tiny little areas, these dAs, but there are thousands, maybe millions of them. How in the world do we add them all up? Well, this is exactly where the definite integral comes to the rescue. Think of it as the ultimate summation button. We just tell it where to start adding from, let's say A, and where to stop at B. And boom, it perfectly adds up every single one of those infinite slices in between. And this right here, this is the master formula. You absolutely have to remember this one. The total area, A, is the integral of y dx from A to B. That's it. Here, y is just the equation of your curve, which is f of x, and a and b are your starting and ending points on the x-axis. This is your key. So you've got the main quest down. But, just like in any good game, there are always side quests, some tricky situations that pop up to test you. Let's look at a couple of common ones so you don't get caught out. Okay, our first side quest is a big one. What do you do when the area you need to find is actually below the x-axis? This is a really common place where students make a mistake, so pay close attention.
Okay, trap alert, listen up. If you just blindly use the master formula for an area below the x-axis, the integral is going to give you a negative answer. Now why is that? Well, it's simple. Below the x-axis, all of your y values are negative. So when you're adding up all the y dx terms, you're just adding up a bunch of negative numbers.
But think about it logically. Can you have negative area in the real world? No way! Area is a physical quantity. It's always positive. So here's the rule, and it's super important. If the area you're calculating is below the x-axis, you find the definite integral as usual, and then you must take the absolute value. Just make the final answer positive. That's the whole trick. Excellent. You've dodged the first trap. Now for side quest number 2. Sometimes the curve is shaped in such a weird way that using vertical strips makes the calculation a total nightmare. So, is there a smarter way, a better strategy for these problems?
Of course there is. We just have to change our perspective. Instead of slicing vertically, we can slice horizontally. Now think about what changes. The thickness of our new strip is a tiny change in y, so we call it dy. Its length is the x value, so our new elementary area, dA, becomes x dy. And now we integrate with respect to y.
This is a secret weapon that can make some really difficult problems much, much easier. All right, you've handled the main quest, and you've conquered the side quests. You are ready. It is time for the boss level. This is where we use a pro gamer move to solve a problem that looks really tough, but is actually quite simple if you know the trick. The final challenge: find the total area of a circle given by the equation x squared plus y squared equals a squared. Now, if you try to set up one single integral to calculate the whole area at once, trust me, it's a world of pain. The algebra gets super messy and it's very easy to make a mistake.
But don't worry, there's a trick, the pro gamer move that makes this boss battle easy. And the secret is one simple word: symmetry.
Here's the brilliant strategy. A circle is perfectly symmetrical, right? It's identical in all 4 quadrants. So don't even try to calculate the whole area at once. Just do this. 1. Find the area of the piece that's in the first quadrant. This is a much simpler calculation. 2. Get that answer. And 3. Just multiply it by 4. And that's it. You have the total area. It's the ultimate work smart, not hard move.
And just like that, boss level cleared. Mission complete. You now have all the core skills you need to find the area under simple curves. Let's just take a moment to do a quick recap of everything we've learned today. So remember these key takeaways. First, the big idea. Slice complex areas into simple, tiny rectangles. Second, always follow your 4-step game plan. It's your roadmap. Third, be careful with areas below the x-axis. Remember, area is always positive, so you have to take the absolute value. And finally, for symmetrical shapes like circles and ellipses, use symmetry to make your life easier. I mean, just take a moment to think about what you can do now. You can look at a complex equation for a curve, and you can find a real tangible area from it. You have basically learned how to measure the unmeasurable. That is the real power of calculus. And to leave you with a final thought, now that you have this new power, where could you use it? Maybe in designing a level for a video game, or calculating the precise fuel needed for a rocket launch. The possibilities are endless. Keep exploring, keep questioning, and I'll see you in the next one.